Welcome back. Previously, we introduced the fundamental concept called the bias-variance trade-off. And in today's video, I wanted to survey the landscape of machine learning algorithms that could be used for either regression or classification, or for grouping observations together in a method known as unsupervised learning. And the goal is to just be a little bit more familiar about what's out there, with the idea being that we can have in mind some minimal set of tools that could be used to augment traditional econometrics analysis. And we can start in the same place that we start with econometrics, which is linear regression. This, in machine learning, is the most basic learning algorithm. And just like in econometrics, if we have a binary outcome variable, the logit model is the place to start. And in machine learning, this is called logistic regression. But as with econometrics, there's a lot of other ways that we can estimate models. So let's think outside the box. And broadly speaking, there's two different sets of machine learning algorithms. One is called supervised learning, and this is just what we would call regular econometric analysis, where we have a y variable and we have x variables, and we're trying to somehow explain y given the x's. And then the other group is called unsupervised learning. And this is unsupervised because there's no y variable, and we're just going to look at covariances or correlations among the x's to try to group similar observations together. And as we've talked about throughout the videos on this channel, econometrics is mainly concerning itself with supervised learning, but we do incorporate unsupervised learning from time to time in the form of, particularly when we want to think about unobserved heterogeneity types. So this is where factor analysis can be useful, as well as the EM algorithm. So now let's dig a little bit deeper in supervised learning algorithms. These include tree models, and basically tree models are a non-parametric bin estimator that makes splits in smart ways that avoid sparse cells resulting. So if a split would result in an empty cell or a really small cell, then it's going to merge it with an adjacent cell. And we can generalize this into forests, which are large numbers of trees. So if you've heard of something called the random forest before, that is having to do with a tree model. You also might have heard of something called neural networks. This is the fundamental unit upon which all of the large language models are built, as well as a number of other artificial intelligence products that you interact with on a day-to-day basis. And neural networks are trying to model the human brain and its system of neurons, which consist of axons and dendrites. And there's an input layer, which would be the x's, and then a bunch of hidden layers or intermediate layers that are arbitrarily connected to each other, and then an output layer, which is the y variable. And these hidden layers are going to non-linearly map each of the successive layers together. And so what you end up getting is like a logit of a logit of a logit in terms of how the formula works out. And it's also interesting to note that a linear regression is a special case of a neural network. We could also apply Bayesian methods to our supervised learning. And we talked a little bit about Bayesian in the context of Markov chain Monte Carlo. But you can think of Bayes' rule as a learning algorithm where I have a prior belief and then I update the belief given the data. And so that's where the Bayesian aspect fits in here. There's also something called support vector machine. And this was originally developed for classification. and trying to separate positive and negative cases by as large of a margin as possible. And it's basically based on representing examples as points in space and then trying to fit the largest separating margin as possible. I would say the methods on this slide are not used very frequently in econometrics. Most of the applicability with econometrics is going to come in the form of tree models and linear regression type of models or logistic regression type of models. Then if we go over to the unsupervised side of the ledger, we've got the EM algorithm and PCA that we've already talked about in the past. And the one we haven't talked about yet is called k-means clustering. And k-means clustering is going to group observations based on the x's, and in particular apply some distance metric like Euclidean distance between different ordered pairs or ordered triplets or however many x's there are. And then from there, you can group observations into the same cluster, and then you can just worry about the cluster and treat the cluster as homogeneous. So we want to choose the cluster labels such that we have the minimal distance within the cluster. And the formula for doing that, or the objective function, is to minimize across my capital K clusters the distance between any given point and the centroid of that cluster. And in this case, we have a Euclidean distance norm. And we're adding up the distance only within observations that are in that cluster. And then this L is indexing like the column of the X matrix. And we can use other metrics besides Euclidean distance. If we have a situation where the Euclidean distance or some other distance makes sense, then this can be a really useful way to do unsupervised learning, to basically take continuous metrics and put them into a low dimensional set of clusters. So it's a little bit different than factor analysis, but it's the same idea where there's like a dimensionality reduction happening. Then a couple of other ideas that you might hear about with machine learning, but are not necessarily going to be useful in econometrics per se. And I just thought I'd throw these in here just for your own personal development and learning, and so that you can make sense of the different machine learning buzzwords that you might come across. One idea is called active learning, which means that the algorithm can choose the next example that it wants to label if it's a classification exercise. And there's also a notion of exploration and exploitation, which is just saying that sometimes it's good for the algorithm to randomly go far outside of its path, or if you want to think about it, far away from the policy function, with the idea that maybe there's something out there that's even better than the current policy being taken. There's two examples of active learning that might be useful for you. So one is called reinforcement learning. And so this is basically the idea where these world-beating chess and Go engines were able to be trained to learn new ways of doing the strategy of the game. And interestingly enough, solving a chess match or a Go game is not that different than solving for the policy function in the Rust bus engine problem. And so you can apply the conditional choice probabilities that we talked about earlier in this series to get computational gains in this aspect. And then another thing you might have heard of, and that I know that you've interacted with on a daily basis, is called a recommender system. So this is the idea that if you're on a social network platform, it's going to tell you who you should follow or recommend what you should be reading or viewing. Probably YouTube's recommender system is giving you the next video in the series that you should be watching on this channel. Maybe you came to be watching this video because of the YouTube recommender system and you've never seen anything that I've produced before. But these recommender systems are quite powerful at delivering what people might be interested in seeing, and that's through this active learning approach. So now that we have a little better appreciation for all of the machine learning algorithms that are out there, and knowing what we know about the bias-variance trade-off, how do we actually go about operationalizing how to find the optimal level of complexity of our model? And that requires knowing about something called regularization, which is what the next video will be about. So hopefully you've learned some things in this video, and I hope to see you in the next one as well.